here with arrows.
Number 14. Okay, so this is y times the sine of x squared. So that means this is our first function and this is our second function. Okay, but then there's the chain rule within that because this has an outside function and an inside function also. Same dealio over here. This is the first one, and here's the second one, and then you have the chain rule inside there because it's the sine of y squared also. So we are using implicit differentiation, we are using the product rule, and we're using the chain rule, okay? All in one. So it doesn't get much better than this, okay? So product rule is the first function times the derivative of the second function. So this is y times cosine of x squared times 2x. That is the first function times the derivative of the second function. The derivative of sine is cosine. The x squared stays as x squared. And then I have to take the derivative of the inside function also. So the derivative of x squared is 2x. Okay?
I have a question really quick.
Okay?
So we only do a y prime because it's the determinate variable.
Correct.
So if you were to switch them and say regard x.
Yes, so isn't that one of the problems that you have to do? Right, so then you switch it around, and any time you take the derivative of an x, it's going to be an x prime, and y is going to be fine.
Wait,
Okay, plus,
I have a question. Why isn't it, because you took the derivative of y?
not yet.
Why?
I just did the first function times the derivative of the second function. Now I'm going to go plus the second function times the derivative of the first one. Okay, so that's the product rule, 1d2 plus 2d1. We have the chain rule in there because we had to take the derivative of the x squared also. Okay, now we do the same thing on the other side. So again, same thing. First one, which is x, times the derivative of the second one, which will be cosine of y squared times 2y, y prime.
I didn't like that.
I don't know why you would, plus the second one, sine of y squared times the derivative of the first, which would just be 1. Okay?
Wait, why? I put it 2y. Why is there y side?
Because if I'm taking the derivative of y squared, which is where this 2y came from, then I have to take the derivative of the y also, and that's y prime. I did. Okay, good. I'm teaching you to hate. That's good. All right, so that's the calculus part, right? Okay, now we need to do the algebra part. And so the algebra part is get everything with a y prime on the left and get everything without a y prime on the right. So this has a y prime, so it's going to stay here. This has, so I did this part. This has a y prime, so it needs to come over here and join its y prime.
I did everything wrong on this.
Good. Okay. This has a y but no y prime, so it stays over here on the right. And it is joined by its friend over here. Like that.
I'm not the opposite, but it's the
Okay.
same thing.
Yeah, opposite is fine. I tried to tell you guys that the other day. If you come up with the same answer, but all the signs are opposite, then that's okay. It just means you put your stuff on the right instead of the left, okay?
Well, the signs are the same, but the order of it is.
Oh, that's fine. Okay, so now I am going to factor out the y prime. And in the process, I'm going to kind of rewrite this in a way that is less icky. So that's going to be sine x squared minus x, whoops, 2xy cosine of y squared. Right?
Yes.
Equals sine of y squared minus 2xy cosine x squared. Okay, so now I need to divide everything by the stuff that I factored out here. And so my final answer is y prime equals sine of y squared minus 2xy cosine x squared all over sine of x squared minus 2xy cosine y squared. Okay?
Why is that here? Because I didn't do your crazy thing.
Oh, that's fine. So you have x cosine x squared 2y or whatever. That's fine.
Yeah.
Y prime is divided by y prime, right?
Yes, Mary, that's correct.
Because, I mean,
Okay, which one are you working on?
well,
Okay, so let's take a look at 20.
November 20th.
I saw the y
Everybody knew
plus
how to do 20.
y cubed, and I was like,
20 is easy.
20, she said 24.
Thanks.
I did
Almost stupid.
No.
She said 21.
Yeah, it's
Should I? 20 is relatively simple. Relatively simple. Simple compared to the rest of the problems that we're doing. The derivative of sine is cosine. The derivative of cosine y is going to be negative sine y times y prime.
Wait, what? Why is it just simple?
The derivative of cosine is negative sine.
Yeah.
The y stays the same. And then I have to multiply that by the derivative of y. Okay, and then sine of x times cosine of y, I need to do the product rule. So the first one, sine of x, times the derivative of the second one, which will be negative sine y times y prime, plus the second one times the derivative of the first. Okay? All right, so everybody with the y prime is on the left. So that's going to give me sine of x, sine of y times y prime minus sine of y times y prime equals cosine of y
Will you always put the y
cosine of
prime
x
on the left?
minus cosine of x. I do. Because I want my answer right on the left, y prime equals, I don't say blah, blah, blah equals y prime. So, but it does, you know, it's fine. It's mathematically the same either way.
what is
So I should probably practice that.
the sine of x times sine of y times? Oh, I see.
Did you find it? You said where did it? You found it?
Where did the sine of x times sine y times y prime?
From this right here.
Did you multiply it out?
Nope.
Or you,
Well, I just got rid of parentheses, so yeah, the way I did.
are you allowed to skip?
Wait, why is that one multiplied?
I'm multiplying 27 now with my own components.
Patiently waiting to write down the answer.
Well, I'm still confused, so I don't have any questions.
Oh,
Oh,
okay.
you just
All
have to
right,
force them
so
to
you
use-
factor out the y prime.
Drink water upside down.
Or swallow air 10 times.
Divide it by the stuff you factored out.
Okay, I've never heard of either of those.
And then swallow it.
Oh, it is anyways.
So that's your answer.
That's what I got.
Okay. So let's just rewrite. Craig's turn. This equation. So the first thing that I would do is I would put y's in for here so I don't get confused.
Why is that equal?
Because that's
You
what
just rewrote
it
the
says.
So you rewrote the f of x as y because we want the f of x
And then you want to, what's it called, differentiate. So this is y prime plus, and then this is the, you have to use the product rule because it's being multiplied. So 1 d2, so that would be 3y squared times y prime. This? Okay, plus 2 times d1, which is 2x, equals 0, because it's the derivative of a number is 0. Okay, and then we want to do math segregation. And so we'll move this over, we can subtract this.
Why would you just, like, never mind, you just do the opposite.
Take one out.
Oh, you just have to do that.
Yeah, I'm just gonna move this over. So y prime plus x squared times 3y squared times y prime equals negative y cubed times 2x. And then what you could just pull out that 1 plus x squared times 3y squared, and then you can just divide this. There's no sign.
That's 100% correct. Yeah.
Okay, and then what, now we need to plug in 1. Okay, so
Hold on, now you need to pause the video, pause button.
okay, so this is your answer for the equation. This equals y prime. So then you're just gonna plug in 1. So 1 negative 1 cubed times.
That's a y.
I was just kidding. So remember that when you see a y, you want to plug in 2, and when you see x, you want to plug in 1. Negative 2
Oh, good
Why
lord.
is it 1 plus x?
times 2 times I should try
Subtracting
this
the y
half of
prime
it.
out of the y prime.
1 plus 2 squared.
No, it's x squared squared, so it should be 1 squared for the x.
1 squared.
1 squared
and
times
then
3
you
times
can
2
square
squared.
Okay, 1
Move on.
times 2.
I finished it.
Calculus makes me want
It's
to
out.
cry.
Squared, okay. And then just do this all out. So 8 times 2, so negative 16. So I think Connor was right. Is it negative 16 or myself? For this one.
I got negative.
Okay, negative 16, so then 1 plus 4, 6, 2 times 4. Okay, and this equals 6.
Okay?
Does anyone have any questions?
Yeah. Yes, it does.
Okay,
Oh, yeah.
23. So now we're switching it around, okay? And instead of saying we're going to find dy dx, we're going to find dx dy. So that means that x is the dependent variable, y is the independent variable. So it's the same game that we've just been playing, except now the derivative of y is 1, and the derivative of x is x prime, and that's what we're trying to solve for, okay? So this is going to be the product rule.
Nailed it, I did it.
So it's the first one times the derivative of the second one, which I'm just leaving as 2y, plus the second one times the derivative of the first one, which now gets an x prime in there. Okay? Minus Product rule for this one. First one times the derivative of the second one. Now the derivative of y is just 1.
This is awful.
And I need to subtract this whole thing. So first one times the derivative of the second one plus the second one times the derivative of the first one. Okay? Plus, product rule again here, 2x and then y cubed. So first one times the derivative of the second one is now 3y squared, plus the second one, which is y cubed, times the derivative of the first one. What's the derivative of 2x if x is our dependent variable? 2x prime. Okay? Right, this is a switch the rule here to make sure you understand the concept. This is a conceptual.
What was the derivative for, the derivative of, x, 2x prime is the derivative of 1?
2x prime is the derivative of 2x.
Okay, because I
Okay.
just put 2, I didn't know.
Oh, okay, yeah. So when we switch it around, now the game is anytime there's an x, you have to put in an x prime. Okay, Gabby? The last one is y cubed times 2x prime. What?
I had length method y prime, but then I checked my x in the back left and got the same thing.
But everything switched.
No, even my x and y are the same. Yeah.
What's the
Oh, you mean the
left
top's on the bottom and the
Yeah,
bottom's on the top?
that's it.
Oh, sure, okay, because this is dx dy instead of dy dx,
Yeah, so
the other way around.
Now you can have a conjunction.
Okay, you can have a conjunction.
Oh my gosh!
Um,
I never had
Okay, and then, sorry, that equals 0, right?
Yeah.
Okay, so now we're going to play math racist again, but this time it's the x primes that stay on the left, and just to make Taylor more frustrated than he already is, I'm going to rearrange these so that they're in the order that I want them to be. So I'm not going to write y squared times 4x cubed. I'm going to go 4x cubed, yeah, y squared times x prime. So that stays here. This thing right here is secretly a negative, right? Because this negative sign goes to both of those things. So that's going to be minus 3x squared y times x prime. Okay, so I've done this, I've done this, and then this also has an x prime in there, so I need to go plus 2y cubed times x prime. Did that. Equals. Now everybody that does not have an x prime in it is going to go onto the right-hand side, and all the signs have to change because of that. So this becomes negative 2x to the fourth y. This becomes positive x cubed. And this becomes minus 2 times 3 is 6 xy squared. Okay? Okay, so like most people that do math, I am lazy. And so instead of actually factoring out the x prime and then dividing by all the stuff that's left over, I'm just dividing all the stuff. What a beautiful answer that is. How can you not look at that answer and go, oh yeah, I know I'm right. That just
No.
feels right.
No, it feels wrong.
Like if you had
It feels
negative
dirty.
2x to the third y, you'd be like, no, something's wrong there. You see that negative 2x to the fourth y, you're like, oh yeah, that's right.
No, I didn't. It bugs me so much, and then I don't know how to simplify it.
Wait, can't. Oh, fun. Do you see why it's called a cardioid?
Looks like a heart.
Okay, so x squared plus y squared equals blah, 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 blah. So we're going to find the, are we finding the equation for the tangent line at that point? Okay, so the first thing we need to do is take the derivative. And now we're back to normal land where x is just x and y gets a y prime. So the derivative of the stuff on the left-hand side is 2x plus 2y times y prime. The derivative of the stuff on the right-hand side is considerably more complicated. Huh? Chain rule, yeah. So I need to do, oh boy, yeah, the product, oh no, product rule.
We have to FOIL.
Okay, so the 2 goes in front.
Yeah, I just kind of.
Everything inside the parentheses stays the same.
I square rooted both sides. Is that?
and then I have to multiply by the derivative of the stuff inside. Gabby, that's not bad, except if you took the square root of the left and got x plus y, then that is bad.
Okay. 7 by the plus.
That's kind of what I
Well, I
thought.
did it both ways, but I'm just saying.
Okay, no, you have to understand the square root of x
I
squared
don't
plus y
understand
squared
the
is not.
by adjustment.
Well, you just have to try some numbers and then you'll know what doesn't.
I feel like it's just in my mind.
So square root is the inverse of multiplication, not addition. Okay. Good. Glad we got that
So
done.
badly.
Okay, so then I think we're done with the derivative, right? Okay. Now, I am going to show you something a little bit different than what Mary did. And that is, I do not have to solve this for y prime right now. I can take and plug in the numbers first, and then simplify it, and then solve for y prime, okay? And that will save me a lot of trouble because,
It'll give you the equation.
yeah, x is 0, right? So if I plug in 0, then this is gone, okay? Y is 1/2, so 2 times 1/2 is 1, so this just becomes y prime. So that's a lot easier. Over here, if I plug in 0 for x, 2x squared is 0, okay? 1/2 squared is 1/4, and 2 times 1/4 is 1/2 minus x, but that is just 0, okay? Times, if I plug in 0 for x here, then that is gone also. Y is 1/2, so half of 4 is 2, so that becomes 2 y prime minus 1, okay? So that is a lot easier to solve for y prime than all of that stuff right there, yeah. Which is not to say that you couldn't do it that way, okay? Multiply out a trinomial, get 9 terms, yeah, good deal.
It was
Okay,
horrible.
2 times 1/2 is 1, so even better, that goes away. So y prime equals 2y prime minus 1. So that means that y prime equals 1. So the slope of the tangent line at that point,
Wait, so why didn't
the
you
weak
just
to
get rid
equally,
of
I'm just going to
turns
throw
out
out
to
there,
be
even though I took the square
Wait,
root, I
what?
still got
you still
one.
got it? Okay. Another conjecture, okay?
Where did your y square go?
My 2y squared right here, I plugged in 1/2.
Oh,
1/2 squared is 1/4, and 2 times 1/4 is 1/2. Okay? Why does what equal 1? Oh, because I subtract y prime from each side. 2y prime minus the y prime is just y prime. And then add 1 to both sides and get y prime is 1. Okay? So now my equation is,
Or you could just do like, you move the 2y over and then you factor out a y prime and then you get y prime equals 1 minus 2, so then y prime
Right.
minus 1.
yeah, however you get it, that's obvious.
Wait, how did you get rid of the 2y?
This one right here? That's what Taylor was asking. I subtracted y prime from both sides. Right? And then, yeah, and then I added 1 to both sides at the same time. So the y primes canceled. 2y prime minus y prime is y prime. And then equals 1. Yeah. All right? Okay. Don't you wish there was someone from another country in this room right now that so they could tell us how to pronounce the Schernhausen cubic? Okay. All right. So maybe someday you guys will have an equation named after you. Okay. Find equation of the tangent line of this curve at the point 1, -2. So here we go again. I'm going to take the derivative. So the derivative of y squared is 2y times y prime.
What do you do?
I'm taking the derivative of this.
Okay, I was
Right? The derivative of x cubed is 3x squared, and the derivative of 3x squared is 6x. Okay? This one I'm going to go ahead and solve for y prime before I plug in the numbers because it's so easy. So y prime is equal to 3x squared plus 6x over 2y. Okay? Yeah, there's some simplifying we could do there, but we'll get to that later. All right, so I need to find the equation for the tangent line at the point 1, negative 2. So if I plug in 1 for x, that gives me 3 plus 6 on top. And I need to plug in negative 2 for y. So 2 times negative 2 is negative 4. So that gives me a slope of negative 9/4 at that point. Okay? So the equation for the tangent line is y plus 2 equals negative 9/4 times x minus 1. You want me to? Okay. So y plus 2 equals negative 9/4 x plus 9/4. So y equals negative 9/4 x plus 1/4. Good stuff. All right, part B. At what point does this curve have horizontal tangents? What's true about the slope of a horizontal tangent? 0. So I need to take this derivative and set it equal to 0. And so
you can't just put maximum.
But it's just the top, right?
So it's just the top that has to equal 0 when you're dealing with the fraction. So now I'm going to solve that by factoring out a 3x. And then one of these two has to equal 0. It's a mystery. Which one is it?
I think it's the 3x.
I think it's the x plus 2.
So that happens when x equals 0 and when x equals negative 2. But it wants to know at what points that happens.
The original.
So I have to figure out what the y values are that goes with those x values. So yep, I'm going to plug it into the original. So 0 plus 0, y squared equals 0. Square root of y is also 0. So that's at 0, 0. That is fun. And then if you plug in negative 2, that gives you negative 8 here. Gives you 12 there. Negative 8 plus 12 is 4. And the square root of 4 is 4. Negative 2. So there's actually 2 points that we get from x equals negative 2. Okay? Yeah, you can do it that way. So 0, 0, negative 2, and
Wait.
negative 2, 2.
If it has 2 x values, then it's not a point.
Correct. And that's
So
why
what's the
it's...
point of working
yeah.
it?
It's your, I mean, I joke about racism in math classes, but you are showing some serious discrimination against implicitly defined functions. Yeah, exactly. What do you got against things that are functions?
Okay.
It's pointless.
Mary, that's not a function. Look how pretty that is.
A function has
2/3.
Hey, Leanne, they're not functions.